Cool. Well, thank you all for being here. Thank you to our panelists up on stage. We've got a great kind of all-star cast of DePIN founders here. My name is Connor. I'm the DePIN lead in BD at IoTeX, and super excited to host this panel and to explore some of the biggest use cases in DePIN across AI, decentralized cellular connectivity, and a few others. So we'd just like to kick off with some short intros from our panelists here. So we can start with Trevor on our right. Just tell us a bit about you and Render and what you all are building.
Great. Hi, everybody. I'm Trevor Harries Jones. I'm COO at Otoy, which is the for-profit side of the Render network. I'm also on the board of the Render network. The Render network is a network where motion graphics artists contribute their idle consumer GPUs to run rendering and AI jobs in parallel at a fraction of the time and sometimes cost.
My name is Mike Horton, and I'm the project creator and lead for the GEODNET Foundation. GEODNET is running a large-scale geospatial reference network, which provides accuracy data to improve GPS at scale.
I'm Andre. I'm one of the co-founders of Grass. We're building a data layer for AI. Right now, mostly focused on public web data, but expanding into other types of data as well. That's more or less it.
Hello, I'm Dennis. One of the founders and CEO of WiFiMap. For the past 10 years, we've been building one of the largest decentralized Wi-Fi networks worldwide with over 175 million downloads, leading the space, using the power of community to build infrastructure for the future.
Great, thank you guys. So I would like to level set a bit with kind of where we've been in terms of DePIN. I would say the term kind of came about in 2022, but there's been projects that have been building in the DePIN space since 2019 and maybe even before then. I think DePIN's first cycle was very much like a build it and they will come type of messaging in terms of like what can we do with token incentives that's interesting, what can we motivate individuals to do on the supply side. I think for this cycle, we've all matured a bit and we can focus more on markets that are in demand and building supply towards those markets. So Andre, I'd love to start with you and Grass being kind of the earliest stage project up here. You all have done a killer job on the community growth and like contributor growth fronts. I think you're probably close to 1 million contributors globally. So if you could just talk a bit about what that journey's been like, building out the community on Twitter, Telegram, and getting to almost 1 million contributors globally.
Yeah, absolutely. Happy to. I'm sure most of you here are familiar with our points system. Heavily incentivizes referrals, which has been, I guess, a very big factor for us in terms of our growth. As we sit today, we're at about 750,000 daily active users. If we included Sybils, that would be 10 million, but we don't like to include those. So 750,000 on individual residential IP addresses on unique device fingerprints. In terms of growth and like some of the few things that we've like played around with in the early days, our very first thesis was, okay, we should make this as Web 2 friendly as possible. This should not feel like a crypto product. And given our cost of acquisition in terms of the supply side is zero, and it's also zero for people that want to join the network. You just hook up your existing device and start monetizing your unused resources. We figured it makes no sense for us to pay for things like marketing and advertising, and we should just build a very strong core community. So we started off with a wait list of 1,000 people who've signed up, and from then, that was about 7 months ago, till now, the only people that could actually join the network were those that got referrals, and the very top of, I guess, that referral tree was those 1,000 people that joined that original whitelist. And when you build network effects like that, you end up having a very loyal core group who were very early, and they help spread the message. And in terms of the message itself, like as we began building, we initially wanted to build web scraping infrastructure for all kinds of companies, ranging from AI to not AI, I guess, to use. And as we were building that out, as we were getting solicited by all kinds of companies that wanted to use our infrastructure, we realized, hold on, there's a lot more value accrual to end users to do the scraping ourselves. And that's when we sort of evolved into this data layer. So,
yeah, no, it makes a lot of sense, and congrats on all the recent growth.
Thanks.
For Trevor and Dennis, I know both of your companies or projects have kind of like Web 2 origins. So and I'll start with Dennis here because I think it's a more recent transition for you. What's it been like to bring a community of contributors from kind of just a Web 2, non-crypto, non-token world into a world where you're now issuing tokens to them, these tokens have value. What's that transition been like, and what are their likes and dislikes with the new model?
Yeah, so in our case, we already had over 13 million contributors prior to launching the token. They were already used to certain rules of the game when we had the point system in place. And given how far Web 2 went as far as frictionless purchases with 2 clicks of a button, Web 3 is still yet to accomplish that, to remove that friction, so to speak. So I think the biggest challenge was just introducing the wallet, explaining to people that there will be a use case of this token. Now there's obviously a use case where they can purchase eSIM data plans in over 80 countries with that token. And overall, the educational portion was a little bit tough. But once the token was launched, we've seen just unbelievable results. We've seen like triple-digit growth in number of hotspots that are being mapped. We saw that the existing contributors actually who understood the game started contributing much more. We saw quality of the data being much better. So it was a perfect fit for our ecosystem to introduction of the token. And we're still going through some hurdles. So I like to approach things in phases. And that's what we've done with the introduction of the token, and it worked out very, very good for us. Now we've onboarded all the contributors, and they all understand the concept, use it. Liquidity is there, so it's a good thing.
Yeah, that's awesome. It's been great to hear that the token and kind of bringing that community into a Web3 whole economy has been helpful and beneficial with like data getting better, more hotspots being added, kind of all that. So Trevor, same question for you. I know there's the OTOY and Render Network kind of history or like kind of comparison that's going on there. Like, yeah, what's it been like to try to get motion graphics artists into kind of a Web3 mindset and space?
So it's been really interesting. We're circa 2017, so even 2 years before that. And I think the biggest challenge is motion graphics artists at that point, and I don't know if it's even the case today, they weren't crypto native. And a big part is the on-ramp, right? So what I really love about our approach is we price our jobs in fiat. And so in many cases, artists who are looking for work to be done don't even know they're part of a Web3 project and don't have to be. And I think that's really important. It's that on-ramp, we essentially abstracted it for them in a way that made it simple for them to understand the pricing being consistent and fiat-based, and therefore get the confidence to use a services like this and grow. And from there, we saw them then learning crypto, contributing wallets, and becoming part of the node operator side. But it really just started with that simple on-ramp for them to get into the project and start using it.
Yeah, no, that's great to hear. I mean, I think fiat fixed kind of pricing model is really important in DePIN. There was a presentation up here this morning from a 6-man ventures kind of research partner about that same exact thing. Is like, if these tokens are going to float in value and sometimes be very volatile, you don't want people to have to pay in that token maybe like a fiat fee that's derived from that token. So the number of tokens might change, but the dollars you're paying for the service wouldn't, which I think is definitely a good goal to have. Last but not least, Mike, for you all at GeoDNet, I know you've probably got a tougher job in terms of barrier to entry for contributors. Like, you've got project-specific hardware. It needs to be deployed in certain locations around the world. So talk to us a bit about what that's looked like. How have you gone to market on the supply side to get people to buy hardware, set it up in the kind of specific locations that you need?
Yeah, I think that's a good point. So traditionally, setting up a GNSS reference station has been something that only sort of governments and multi-billion-dollar large companies do, and has run sort of $50,000-ish to set one up. So one key point is we've had tremendous innovation on the hardware to allow you to put up what is really an absolutely perfect geospatial reference station for on the order of $700. And that's really allowed the network to grow really quickly. And I think the second key piece beyond the innovation on hardware is we've taken a lot of inspiration from the DY projects. And the DY projects came earlier than GeoDNet, but they learned a lot about sort of overcrowding and how to incentivize a token system that will create a network that has even and high quality coverage, because that's really what the data users will pay for. They won't pay for a network that has gaps. They won't pay for a network that has performance issues. So we set up a system with hexes and added a location-based NFT so that the first station that really achieves these high-quality metrics that are needed could then be protected of their earnings for the lifetime of the device. And I think a couple of those things really attracted people in from the DY community who saw that this could really be deployed in a way that they could count on a long-term sort of sustainable token rewards from a GeoDNet station.
Yeah, for sure. And congrats on the raise you guys announced today, by the way. Really great seed round you put together. And I would ask you kind of the stats, but I read the blog post, so I've got it all up here. But it looks like you would need 20,000 kind of nodes globally to have 100% coverage.
Yeah,
Is that
so
right?
there's two ways to think about the coverage. So for developed world countries where there's some pretty established use cases for what we do, which is called RTK, which includes automotive, IoT applications like drones and smart mowers, agricultural applications like tractors. To cover that developed world where there's already a ton of RTK users, we need about 20,000 stations. We've modeled our tokenomics around 100,000 stations, which would allow for additional redundancy, but also perfect coverage over areas that are not as developed. And we have put a big emphasis on working in some of those markets and establishing sort of the first ever reference station networks in some places. And it's really interesting. We had our first customer, there's a government, come to us and say they're going to switch to using GeoDNet, and that's the country of Sri Lanka. So that's really,
Awesome.
I think, a pretty incredible accomplishment.
Yeah, that's super cool. Okay, so 20,000 nodes to cover the whole globe, and that number could potentially increase over time as there's more usage in terms of the kind of density of nodes you'd need.
Well, actually, it doesn't, you don't need more nodes to cover more people. So one of the unique things about Geospatial, it's really a sensor network. So one node can supply all the consumers. If everybody with a cell phone who wants to have better GPS location, they can all use one node and one hex. So that's another interesting aspect of the GeoDNet project is we really can kind of constrain the node growth, and we have a very deflationary burning policy with the token that actually has a decreasing supply. So what we need is good nodes in those locations and some redundancy, but we don't need to continue to add more nodes as the number of users on the network grows. And so I think that lends itself to a very value accretive set of tokenomics.
Yeah, no, that's awesome. Okay, so we've covered kind of supply side and go-to-market for contributors for all of you guys. I want to talk about demand now. And before we jump into kind of project-specific nuance, I'm just curious, kind of open-ended question for all of you. Anyone can jump in. Like, how does kind of BD and sales work for your networks today? Is it like the core dev team or the operating company doing it? Do you like that model, or would you prefer if the community was kind of a service provider and selling your service as well? Like, how do you see it both now and in the future in terms of selling the services you're offering?
I just do it myself.
Would you want like a third party to come in eventually?
I mean, as we
do the
grow,
same?
yeah. I think everyone on this panel can probably agree. The best person to sell a product is the founder. And if you're bootstrapping your early demand, like that's probably the best place to look. The person that understands the product the best, that understands the value add, that understands the competitive landscape is probably the person that you want to be selling it. So between myself and my co-founders, we've been handling that.
We're definitely the same. So the founders are all involved in the demand side heavily. But what we've tried to do is to also create strong incentives for Web 2 partners to resell the GeoDNet network, and that's worked very well. And so we have a strong reseller program. That's helping us scale to a lot of applications.
Yeah, we kind of have twofold. The one is for partners who want to come in. We have a compute client program, so it's inbound with grants and really community driven there. On the motion graphics side, though, it really is word of mouth. I mean, you know, at the price points you're talking, using these services, it's not a BD play, but really more one of the word getting out there, how amazing the service is or how cheap it is. So it's kind of twofold, grants and then product itself.
Dennis, anything to add there?
Yeah, in my case, I also do all the business development myself. I've closed every single contract that we have in this company by myself. I actually have now, as of last year, a business development person who is yet to step into those shoes, so to speak. But I'm always open to third parties or anything that can help me close those deals and free up some of my time.
For sure. Yeah, no, that makes sense. So yeah, talking a bit more about the demand side, AI is obviously all the rage right now. So I'll start with Andre over here. If you could maybe just lay out kind of the supply chain of AI from kind of raw data coming in at the top to models and their outputs at the bottom, and where Grass fits into that picture.
Yeah, definitely. I guess everyone here knows you've got basically two inputs into any AI model. You've got your parameters and your tokens, and in other words, you've got your compute and your data. And as you scale one, you have to scale the other one linearly. So if you want a more powerful model, and you just add a ton of parameters without adding more quality data, you're actually creating a model that is not compute optimal, and you're wasting electricity and money. So as far as we're concerned, like as I mentioned earlier, we're just focused on the data side of this. And the way the supply chain works, I guess, would be we have all these hundreds of thousands of agents that are living on residential devices that are scraping the web, and they're doing it concurrently. And that node is also just processing raw HTML into structured data, sending it to a database, and then we run embedding models to vectorize that. Once it's vectorized, in other words, you turn a lot of language data or multimodal data into huge vectors of numbers, you can basically ship that into an AI model, and that's where, for now, our job ends. That being said, we are training an LLM to actually automate part of that processing for us. If anyone here has done any sort of work with web data, it's such a pain. Writing custom scripts for every single type of website, custom crawlers for every single type of domain. And one thing that LLMs are very good at is actually processing any sort of garbled noise into something useful. So right now we're actually training a specialized LLM to automate a lot of that. Turns out that about 80% of the time that it takes to, or like the human hours that it takes to build an AI model is playing around with data and making it clean and making sure it works fine. So, I mean, in some sense, we're kind of like this decentralized common crawl, but we do a bit more work. If anyone here has ever used common crawl, it sucks, right? Like 80% of it's unusable. Like the links are broken, like data's outdated, like all the HTML is in there. You have to clean it yourself. So, I mean, in terms of like value proposition for anyone working in AI, for us, it's like we've got all this working for you. We can do it for cheap because it's running on the edge, and we've also, I guess, accrued multiple what would otherwise be middleware providers into a single product. And I guess like the other competitive edge too is that when it comes to real-time inference, right? And like inference is basically you're sending a prompt to your model, which has been pre-trained and then fine-tuned. A lot of people don't really think about this, but inference is actually adding data to your model to get an output when you give it the prompt. And one really interesting thing you can do actually when you're querying a model that doesn't have the information that you want of it is you can actually have the model go and scrape the web in real time, structure the data, add that to your prompt, add that to your context window basically, and then get you an answer that's informed by real-time events. So that's something else that we're working on.
Yeah, super cool. And how does the idea of, or like the movement behind democratizing AI play into like Grass and what you all are doing? Like what, structurally about the business is enabling that?
Yeah, absolutely. Like if you try scraping the internet using an AWS server, you're gonna get blocked like very quickly. Try rotating IP addresses, that'll get expensive. And 90% of the time, you'll either just get honeypotted or blocked from like the first web request. It actually becomes unusable for you. And the reason web servers are blocking programmatic data, or rather programmatic web requests, is because they're finally realizing that the information they're putting and hosting on these web servers is actually quite valuable. Not just to the people that they're trying to show it to, but the people that are trying to use it to train some sort of model to derive some sort of insight. The issue, though, is that when you're scaling a model with data, it's very heterogeneous. Like compute is homogeneous, right? You're looking at floating point operations per second. You can add more compute. Like people kind of understand how you can scale a model that way. when it comes to data, a lot of companies don't know what price to put on their data. So instead of trying to figure out a way to sell it, they figure out ways to block people from scraping it from their websites. Because we're running on all of these residential devices on residential networks that are used by real people, these web servers have no way of differentiating our network from some crawling agent. So yeah, actually, I completely forgot the question you asked me in the first place.
No, I think you basically answered it, which was just like,
oh yeah,
like
the
how are you guys
democratization.
enabling?
Yeah. Sorry, and then like the other thing too is like you've got two problems or two ways of poisoning data. And the first one is kind of what I just described is a web server messing with a crawler. Like one of the most popular ways to poison a crawler is to go and either give it fake news, which is like on a hidden link that only a crawler could find and not a real person, or just send it into a rabbit hole of millions of fake links, and then it just gets lost. And then you end up having like this poison machine learning model. And that happens at the web server side. But like the other one that a lot of people don't talk about is if you think about an LLM and the way it operates, it's like the core functionality is very similar to that of a search engine. I have believed for some time now that or LLMs are going to follow in the same footsteps of value extraction as search engines have for a very long time. Because if you think about it, like how do people poison search engines? They'll play around with SEO, or they'll just pay for advertising. But the former is much more likely. The equivalent of playing around with SEO in an LLM is actually to poison the data set retroactively. So a bunch of data got scraped. You are Adidas, and you want 100,000 instances of Adidas is the best shoe in different, worded in different ways, spread throughout the data set. You can actually add that, and when you're looking at petabytes of data, like the scale of data that goes into these AI models, it's almost impossible to detect. And part of what we're doing on chain actually is verifying the requests themselves. So we have a proof of request mechanism that can actually augment a data set, tie a line of a data set to a web request that happened at some point in history. And if anyone ever plays around with that data or tries messing with it, it's very evident, and it's not hidden. And we add a bit of transparency to these open source data sets.
Super cool. Yeah, there's this whole like cat and mouse game going on the internet between web crawlers and I guess owners of data sets that I had no idea about. Trevor, for you and Render, I know you've added some kind of AI clients recently or AI partnerships where there's going to be some companies that are using Render Compute for their kind of AI-related jobs, but I know the kind of core use case for Render is obviously rendering and in the graphics space. So if you could talk a bit about the use cases, maybe first on the core kind of rendering use case, and then also what's going on the AI side.
Sure. Okay. Yeah, there's been an absolute glut of recent projects emerging on the compute side, and we love it. We really view those as clients who, if they aren't rendering, aren't competitors, but potential customers who we can bring to the network. And just the last 4 months or so, we've brought 4 of them on in IoNet and Beam and FedML and Asana. So that's been great. When you look at the hierarchy or the GPU world, there's an absolute shortage of very high-end GPUs, the H100s, that really have a good use case for large language model training. But when it comes to inference and some of the other models, particularly on the video space, you don't actually need the firepower you have in an H100. In fact, many of the video customers we talk to actually use much less performant models that are pretty close to the consumer models. And on the consumer side, there's actually a glut of available consumer GPUs. The estimates are the 250 million plus out there that could be used for at least rendering and a subset of that for AI. So there's a lot of them. The great thing in terms of the pricing hierarchy is that same GPU, if you take an NVIDIA 4090, the revenue that you can generate doing rendering on it is just over 8 times what you can do on a general purpose compute model. So the rendering is definitely where the money is at the moment and where everyone wants to get into. And it's really a key part of the model that, as a node on the render network, you can ultimately at some point do both and have access to those higher end render jobs as well as compute client jobs. So, that's what we're seeing on that front. We're seeing such a change in the video space. Sora just 2 weeks ago that we're really excited at what we see coming this next year in terms of diffusion models and other models besides LLMs, and the demand really coming from those seeing success and finding the right product market fit.
Yeah, no, 100%. And I think like it seems like the very high-end GPUs, that market is supply constrained, but it sounds like you're saying that the kind of consumer-grade GPUs or the cheaper GPUs, there's actually a lot of them, and they're not being like leveraged as efficiently as they could be.
Yeah, very much so. If you think all the Ethereum, proof of work miners that were consumer GPUs that are now idle from moving to proof of stake, we had a wait list for a number of years because there was just an abundance, and it's been great to now open that up for the compute clients.
Yeah, no, 100%. Mike, for you and GeoDNet, let's talk a bit about the use cases you're serving, the types of customers, and maybe like how the data that you're providing them impacts their businesses.
Yeah, so we help people achieve higher accuracy in location. So it's a locationing service that can provide, instead of 3-5 feet of accuracy that say a GPS would provide, sub-inch accuracy. So classical use cases that we do service are surveying and construction, drone scanning, but there are also a lot of exciting new applications that, because of the affordability of GeoDNet relative to traditional services in the consumer space. So we're launching with a company that's doing a smart mower, a smart robotic mower that's very affordable, doesn't require any installation of any perimeter wires or anything like that. So we see the consumer space, and including drones and mowers, but also automotive and even mobile phone applications, as really being one of the key things that GeoDNet enables.
Yeah, that's awesome. And I don't know if you guys have seen the movie Inception, but they have like tractors and farm equipment that operate automatically, kind of in a robotic way, and they're guided by GPS or maybe other RTK type systems. So that's why I love DePIN. It's just like there's companies up here that are building the future, literally. Super cool. Dennis, for you and WiFiMap, would love to talk about the demand side for you all, kind of what's generating revenue today. Maybe I know the primary kind of revenue generator within the app is probably just wireless connectivity, right, and VPN services. But how are those demand segments going? What are you looking towards in the future in terms of monetizing as well?
Yeah, so the demand side is, initially the product was built mostly for travelers, but over the years it transformed into this not only travel companion useful app, but something that people use as remote workers. It's very popular with them. It's very popular in places with just lack of free internet, just lack of connectivity. In United States, it's mostly people that just want to save money on the internet costs. As far as our revenue sources are obviously eSIM data plans that we offer in over 80 countries, and those can be purchased either via fiat or with our Wi-Fi token. So the use case is the following: that one doesn't have to spend any money on acquiring any hardware and can just participate in mapping Wi-Fi's, running speed tests on a bi-weekly basis with airdrops for those users. They get rewarded with Wi-Fi tokens. Those tokens they get to spend inside the app on getting anywhere from 1 to 20 gigabytes worth of data. So for a lot of people, there's no more need for the actual mobile operator anymore, because they have, between the Wi-Fi and the eSIM coverage that we provide, they have all their connectivity needs handled. We do offer as part of the package, in addition to eSIM data plans, we offer offline maps, we offer VPN services, and those are going to be soon available via Wi-Fi token purchase as well. As far as where we're looking in the near future is, over the years we've perfected our crowdsource. And now we have millions of people that are just eager to do more. So we're going to open up ability to map and populate our map with stuff outside of Wi-Fi. we call them ETAs, like essential travel amenities, so like restrooms, water fountains, just venues that accept cryptos as payments. Will let community just map out basically all the stuff that's missing from Apple, Google, and we're gonna bring all that stuff on chain and allow the next level of developers to use this data to build their solutions.
Yeah, super cool. So it sounds like maybe an advertising use case around different points of interest, and say if there's like a cafe or a restaurant that wants to appear larger on the map, they could maybe pay or stake tokens for that. Is that the idea?
Yeah, absolutely. So we're going to be approaching venues. We already work with a number of them where they add their Wi-Fi's to our database, but we want to give them ability to stand out on the map with a bigger logo, just differentiate themselves among competition, provide some sort of a discount for our community, so like a $2 off coffee or donut, so to speak. And they'll have an option of either paying for this advertisement or just taking Wi-Fi token for being on that map.
Sweet. Yeah, no, I've had the app for a while. I've definitely played around with it, added some hotspots, earned some tokens, which has been really cool. I think I'll actually be an eSIM user potentially in the future because I just got an iPhone 15 to get Helium Mobile. That's like my primary carrier now. It works fantastically well. It's like, they're partnered with T-Mobile, but whenever I travel to other countries now, I don't have the AT&T like one-day pass. One-day pass for $5. So I'm going to need connectivity overseas, and I think the easiest way to do that's probably to use the second eSIM slot on my phone, and work with a provider like you guys that has coverage or can provide coverage in those countries. I think I need you to add Costa Rica though. I don't know if I saw Costa Rica.
Costa Rica, I have to
Yeah.
double check on
We
Costa
need
Rica.
Costa Rica.
There's like 86 countries at this point, and we keep on making partnerships to expand that coverage to make it truly global. And even myself, like a T-Mobile customer, I remember flying into Ukraine, which was one of the countries covered by T-Mobile roaming, and then I find myself like, it shows 3G, but I feel like I'm on 2G. The phone kind of works, but I can't really get to my banking app or, watch anything. So it's kind of semi-works, and eSIM obviously solves all of these issues.
Yeah, for sure. I mean, just as an aside, like I think the telecom industry, at least itself, is becoming more and more friendly to the consumer. Like the advent of eSIMs and lowering kind of switching costs for people like me and all of us up here has been great. Like I bought an unlocked iPhone 15, wasn't locked into any carrier, can use Helium Mobile, can get a second eSIM with WiFiMap when I travel. Like it's just becoming more and more just consumer friendly, I think. So yeah, that's all the kind of set down questions I had for you guys. Thank you for being here. I think if there's any questions from the audience, would love to take maybe one or two. Right up here in the front.
What do y'all think about AI teams? Everyone's talking about one AI, an AI, the AI. We have multiple projects with different AIs. Why are our AIs working as a team? Like cross-chain AI saying, that's a good picture. This is a cool picture. Let's take our things together, right? And make a third picture, like our final draft, the team project submitted for the grade, as opposed to everyone's fighting or competing or, programming it one way versus someone programming it another way. And,
You're referring to a lot of small AI models working together as opposed to one very large one?
Basically, if we're decentralized,
Right.
we have one AI.
Got it. Yeah, it's a fair question. The vast majority of actually recent development in open source AI has been in smaller specialized models that use differentiated data. You can actually do a lot of things with very powerful models like GPT-4, but in order to query a GPT-4 for like regular use, it gets very, very expensive. And one thing people are realizing is you can actually create a synthetic training set using a very powerful model and train a much smaller one that only knows how to do one thing very, very well. There's a lot of research going on in that space right now. Now, to your point about these models interacting, doing things together in an automated fashion, a big problem right now with LLMs is being able to chain them together. The issue there is that error propagates. Let's say you have 90% accuracy. if you chain two of them together, you have a 29% chance of it just not working. It's like the AIs, they kind of play broken telephone with one another. There have been a lot of experiments. You can look this up. I think look up AI broken telephone or something like that. But I remember someone showed the picture of the Mona Lisa, asked the AI to describe it, like went through a few more steps, then tried to recreate it, and it gave something completely different. So there's still a lot of work to be done there. And that's also part of why for like cross-functional use cases, people are still relying on very large models. But the second that nut's cracked, you can probably expect AI wave 2.
Cool. Yeah, it sounds like error is multiplicative across models when you combine them. I didn't know that's how the math worked, but that's cool to think about. Okay, I think we're good. Thank you all for listening to this panel. Thank you to all the panelists for sharing some insights.
you.
Thanks, Connor. Thanks, everyone.